The era of commercializing space is here. As more private enterprises rush their way up to space, it will soon become a booming market. Just like any other market, there are sellers and there are buyers. And the sellers are quick on their feet to set up shop. We are at the brink of making space exploration financially viable, as technology is drastically improving and logistics are getting much cheaper. Between 1970 and 2000, the cost to launch a kilogram of payload to space remained fairly steady, with an average of $18,500 per kilogram. In contrast, for a SpaceX Falcon 9, the rocket used to access the International Space Station, the cost is just around $2,700 per kilogram. Just being in space is not enough. By its very nature, a private enterprise has to make money to stay in business and keep the shareholders happy. There are quite a few ways to profit from space, and surely more innovative ways will be discovered in near future. But in this video, I'm going to talk about 3 distinct ways to make money in space. The oldest technique is satellite imagery. This is the first image from space, and it was taken on the suborbital V2 rocket flight launched on October 24, 1946. Taking picture of Earth from space is a lucrative business, not because Earth is an upcoming Instagram influencer, but because of navigation. Making maps of road physically are expensive and hard to maintain, so GPS and satellite imagery is used more often. Governments also use these images for surveillance of their own country and sometimes other countries as well. Albeit, most Earth observation satellites use visual spectrum, some satellites use radar that gives them some unique set of advantages. Like this one, RadarSat-2. It's a multi-billion-dollar satellite heavily used by the Canadian Space Agency. Because radar imagery can penetrate through clouds and darkness, it is uniquely suited to provide reliable and continuous monitoring. It works like the eye of the Canadian government to monitor its territory. A radar satellite never goes blind in the high Arctic because it doesn't exclusively depend on sunlight to operate. Civil, commercial, and defense organizations around the world rely on radar imagery to stay apprised of their areas of interest regardless of light or weather condition. Unlike geosynchronous satellite that's used for TV and other communications, satellite whose sole purpose is to take pictures doesn't sit at the same place for too long. They are sun synchronous, which means they sync with the time of the day rather than the place on Earth. A satellite that goes over New York at 10 AM will also pass over London at 10 AM. This orbit type is crucial because satellite imaging is about detecting change from day to day, month to month, or year to year, and an image taken at 10 AM is going to look very different than one taken at 6 PM. This orbit type allows the satellite to pass over the entirety of Earth once per day at the same time, so the light conditions look the same. The fact that these satellites have to, by design, pass over the entire world is quite useful. Not only the satellite maps the entire world, but it can use this data for humanitarian efforts. There is obviously a lot more demand for satellite over developed countries, but underdeveloped countries do find those imageries very useful for keeping track of settlements, wildlife population, and disaster management. The biggest player in this segment is Maxar. It's an end-to-end vertically integrated company that makes their own satellite, launches and operates them, and extracts data from images for their customers. With more than 80 satellites on orbit and 3.8 billion monthly users, from maps to rideshare apps to geospatial intelligence for the US government, they have successfully cornered this segment. and Jeff Bezos is aware of it. He has recently paved his way to make news headlines by going to space. And here comes our second technique, space tourism. Touring space is fundamentally different than touring somewhere like Paris. Because in space, there's not much to see and the trip will last about 10 to 90 minutes. The best you will get is a few minutes of microgravity, which is when gravity feels extremely weak. That will give you the chance to bounce around a spacecraft weightlessly. It's more of a bragging right, albeit an expensive one. These joyrides go 62 miles upwards and cross the Kármán line, the internationally recognized border between Earth's atmosphere and space. So it's about legally touching space and coming back down. According to Matthew Hirsch, a historian of technology at Harvard, compared to NASA space vehicles, they are clever amusement park rides with minimal utility, intended to support a tourism business that has never been part of NASA's charter. Still, Blue Origin and Virgin Galactic have put their back into it, as this venture can be used to make some quick money and gain technical experience for something far more ambitious and science fiction-like, and that is asteroid mining. As Blue Origin suggests on their website, Blue Origin believes that humanity will need to expand, explore, find new energy and material resources, and move industries that stress Earth into space. We use a bunch of rare materials to satisfy our need for tech, infrastructure, and daily commodities. To gather these materials, we still follow the old way of digging them out of the ground. But mining on Earth has endless harmful effects. The mining industry is directly responsible for air and water pollution. It destroys entire ecosystems. Mining has ethical issues as exploitation of workers, locals, and biodiversity, which are far too common. And rare materials are frequently used as bargaining tools for politics, to wage war, and to impose sanctions on countries that depend on those materials. However, asteroid mining does bypass most of these problems, as asteroids have no locals to exploit and no country to wage war with.
The first trillionaire there'll ever be is the person who mines asteroids for their natural resources. I'm just saying.
So how do you go around gathering these trillion-dollar resources? The idea is relatively simple. Step 1. Choosing an asteroid that does have the metals we are looking for. Step 2. Drag it somewhere safe where extraction can be performed. Step 3. Send the useful stuff back to Earth. And all this process have to cost less than the worth of those metals. Asteroids are heavy rocks made of metal and ice. They are the debris of the cloud that formed planets 4.5 billion years ago. They are found between Mars and Jupiter in the asteroid belt or in the Kuiper belt, which is just outside the solar system. Now, how do you choose which asteroid to mine? There are 3 kinds of asteroids: S-type, M-type, and C-type. S-type is stone-like, which are kind of useless as stone are the last thing we need from space. We will try to avoid them. M-type is where the money will be made. These are metal-rich and contain pure heavy metals like platinum, iridium, osmium, and gold. One of the most famous M-type asteroid is the 16th Psyche. It gets its intriguing name Psyche from the Greek goddess of soul who was born mortal and married Eros, the god of love. And space miners will love Psyche a lot, because Psyche, according to Forbes, could be worth about $10,000 quadrillion. To put that into perspective, it is worth as much as 70,422 times of global Earth's economy. Though this number should be taken with a large pinch of salt. After all, if we were to bring such enormous amount of metal into Earth, then it would likely collapse the raw materials market, which will immediately reduce its value. 16 Psyche will be reached by NASA in 2026, but mining will start much later. This is a piece of 16 Psyche that has fallen on Earth, a glimpse of what wealth we can get our hands onto in near future. The third type of asteroids are the C-type. Though they are not stashed with gold, but they do contain something far more useful in space: water. This water can be used as fuel, which will allow spacecraft to carry less themselves and increase efficiency, which will bring the cost down. Once we have selected the asteroid, it's important to extract the metals out of it. TransAstra Corporation has found innovative ways to solve this part. With highly concentrated sunlight that can penetrate through the asteroid will be enough to break them apart, and centrifuges separate dense from light elements. To send back these elements, reusable rockets will be essential. And we have seen significant improvement in this part from companies like SpaceX. Heat-shielded capsules will also be used to keep the metals safe from the heat that will be experienced while returning to Earth. Being in space is a long-term initiative, and commercial entities cannot thrive in a market where there is no obvious return on the investment. When we imagine a future of space industry, we are imagining a sustained business, but going to Mars is not sustainable on its own. We can say the same about space race 60 years ago. But with hindsight, it was an investment that paid off because space now has delivered back. Space today is an integral part of how we view the planet. Communications, imagery, climate science, defense and intelligence, and security applications, all of those are fueled by space exploration that took place before. Whereas commercial enterprises think about what endeavors will bring return on investment, governments have the time and financial ability to do what has never been done before. Commercialization could just be a detour to humanity's inherent need for exploration, to seek what is hidden behind the sky.